What's up guys, welcome to our computer networking final project, which is a DNS and DHCP parser. Our group features Master Leo, Master Jim, Master Yufeng, and Master Ken. And now let's first take a look at the overall overview of our whole project. So our project is divided into 5 parts. The first part is the input byte from file, and the second part is segmenting data, and the third part is decoding IP, Ethernet, UDP data, and the fourth part, decoding DNS data or DHCP data. And 5, and the last step, is output to YAML file. Now let's take a look at how does it actually work on our computer.
Okay, now I'll show you guys how to use our program. First, we go into a folder which contains our hex dump file. We can see the hex dump file contains multiple packets. Now we'll use our program, DNS DHCP parser. We tell it which file to read, where to output the file, and use -v to turn on the verbose mode. Now the program finished parsing the data. It prompts us if we want to view the file. We select yes. Now the application will send us into a Vim interface where we can view different messages and search for specific keywords. And then, after finishing, we can quit the interface.
And now we're going to be looking at some of the example code, and we're going to be displaying mainly these 3 parts of the example code, which is segmenter of Ethernet, IP, UDP, and their decoder, and also DHCP decoder and a DNS decoder.
Hello everyone, I'm Yufeng. Next, I'm going to talk about the segmentation of the data and the decoding of IP, Ethernet, and UDP header. First, for the segmentation of the data, because Ethernet, UDP, and IP header all have fixed lengths, so we can simply segment the data by slicing the byte array at a given position, as shown in the graph in the slide. As for IP header, the decoding of IP header includes the segment of different fields in the IP header and the decoding of some specific fields. We know most of the fields have fixed lengths as well, so this can be done by simply slicing the IP array as well. As for the decoding of IP data, we have a special function called hex to decimal IP address, which can convert hex code into a IP address containing decimal numbers. And some other decoding are implemented by a IP protocol lookup table and some bitwise operations. As for the decoding of Ethernet data, it is done in a quite similar way as the IP header. We first segment the different fields by slicing the array and use a Ethernet type lookup table to decode the values in these fields. And last, for UDP data, we don't need a separate function to decode the different fields, and we simply need to segment the different fields in UDP header, and in that way we can decode the UDP header.
So after talking about the segment of UDP data, let's take a look at how do we segment the DNS data and how do we proceed to decode all the DNS data. So first of all, we pass the whole data into our main function, and they're going to be divided into different separate parts, like the UDP part or the IP part. And then for the DNS part, which we get out of the original data, is being passed into this function called segment DNS, which takes in a byte array and returns a segmented DNS data. So by the headers and by their length in each field, we get to divide the whole byte array into these separate different fields like transaction ID, flags, questions, answers, authority, etc. And after that, we pass them into the DNS decoder to actually decode the message. And this function shown on the right accepts the segmented DNS data and split it into displayed fields. And after splitting them into displayed field, we decipher or we choose not to decipher based on the needs. And most field does not require further decoding except for flags and DNS records, which are going to be explained more detailedly afterwards.
To decode the DNS record, we first need to read the domain name. It is represented in the record byte array, which always starts with the length of a domain field followed by the ASCII representation. Or in the case of compression, the byte starts with C0 and then jumps to another domain field, so we recursively call the function with the compression pointer. After we have the read domain name function, we can then decode the DNS records through the different number of records decoded previously. We keep track of our pointer position in the byte array using a pointer variable and call a calling function for each of the 4 types of records.
Okay, now let's talk something about DHCP decoding, which is also one major challenge in our project. First of all, let's take a look at the main function of the code, which is decoding DHCP options from network data. This is very similar to DNS main decoder function in that DHCP also captures the segmented DHCP data and further segments it into different fields. But actually, most fields are quite straightforward and do not require further decoding. For example, all of these fields, except for the options, just needs 1 or 2 steps if we have the input of segmented DHCP data class. The major thing to deal with is how we are supposed to decode DHCP option fields. In order to solve the question, let's first quickly recap what the DHCP option fields look like, which is the desired output of our project in DHCP. So in the field of front end, the decoded data looks like that. This is in the shape of a dictionary. There are many fields, and each field have different forms of values, including another dictionary, like parameter request list, or a string, like hostname. So therefore, in order to realize that, we introduced a DHCP options lookup table, which maps the option code into its name and its corresponding decoder function. After doing that, we utilized the lookup table and wrote the main function of option field decoder. How it works? Actually, it traverses the input byte array and extracts the option code, whose length is 1 byte, and option length also 1 byte, and finally, the succeeding length of data, which is fed into the corresponding decoder function to get the desired output. After doing that, then it is very easy to implement the corresponding decoder functions. The implementation is ICP-ish, just one basic Python data structures, and it is very easy to get the desired output. Also, it's worth mentioning that to find a very complete version of the parameter request list table is rather hard. Our team spent relatively long time to find the version as complete as possible, though there are lots of fields not used and bypassed.
Now for the file I/O part. Our program takes command line arguments using argparse. It expects a file name as a positional argument, which should contain the packet data to be analyzed. Other arguments include -o or --output for specifying the output file, and -v or --verbose for enabling verbose mode. After being processed, the user is prompted to view the file in a Vim interface with searching and folded views.
Alright, this is all we have. From the above content, you may well see that this is an A project. Thank you so much for your attention, thank you for your listening, and we'll see you next time.